So I'm Syed Abuthahir, and I'm here to present this e-content on the topic edge computing. So I'm assistant professor working in the Department of Computer Science and Engineering at Madanapalli Institute of Technology and Science. So I'm going to give a brief introduction about the topic edge computing in this e-content video. So first, about edge computing, let me define what is meant by edge computing. So edge computing is an extended technology of cloud computing. So we have a very good introduction, or we have familiarity with cloud computing. So I will make a revision about cloud computing and the other classification of cloud computing also before going into the topic edge computing. So cloud is technology which is used for storing the data or sharing the resources wherever it is required, whenever it is required. So anywhere, anytime access is provided by the on-demand cloud service. When we are using cloud service for the past few years, we were facing some difficulties, and there were a lot of drawbacks in the cloud technology. So to overcome this the drawbacks of the cloud technology, new improved version of this cloud, or extended version, we can say that extended version of this cloud technology is nothing but that fog computing, cloudlets computing, edge computing, all these technologies as an extension of cloud technology to overcome the drawbacks, whatever the drawbacks are there that is faced in the cloud technology. So coming to edge computing technology is a distributed open platform at the network or at the edge of the network, or which is very close to the IoT devices or the devices which are involved in the network connections. They usually integrate all the capabilities of the network in which the device is available, and storage and various applications. Edge computing is especially used for time sensitive application over the internet. There are several applications which are much sensitive with the time, which means the delay in accessing the resources or in accessing the network is going to affect the application's objective, and hence such time sensitive applications are going to depend on this edge computing technology, which is an extension of cloud technology. So our scientists or the research people, those who are working in edge computing, have predicted that a report stated by Million Sites that edge computing will reach a market of more than 3 billion by the year of 2027. So because there are millions of devices, IoT devices, which is keeping on increasing in the internet. We can note that everything is becoming converting to smart. We are going towards a smart technology, going towards smart cities. So everything is becoming smart. So IoT devices are involved. So since IoT, more number of millions of IoT devices are involved in internet connections, applications such as very time sensitive application which depend on uh, very quick response from the cloud, so which is a drawback of the cloud also. So we are extending the cloud technology towards cloudlets and fog computing and edge computing for these time sensitive application. For this edge computing technology is evolved. So let me tell you how this edge computing is going to affect with the help of this small diagram. So we can see that in this diagram, there is one application called smart meters, smart health system, and here smart home, and here smart parking system. So which then smart transportation over the road. Okay. Then smart sea monitoring. So here you can see that so many applications are there. So if I take the smart meters, these meters are going to calculate how much resources or electricity or water, whatever the meter is concerned for, it is going to calculate the consumption of the resource for which we have fixed a meter. So it is a highly time sensitive application. For example, means here there is an edge server. So whatever the data generated from this application smart meters, it is going to be offloaded to this edge server, and it is going to be processed in this edge server only. So now all the data related to this particular application is going to be taken care by this edge server, which is very close to the end devices, end users of the network. So the edge server is a high capability, it should be a very high capability server. Okay. So all these devices are said to be smart devices since they are connected to internet. So this edge server, which is going to do all the computations, task computations or storage related to these end users. So now some MB or some GB of data is generated by these IoT devices, and they are not going to be stored only in this edge servers. Only a certain data which has to be, after all computation, which has to be stored remote to the cloud, will be transferred to this cloud server. Not all the data. We are not going to push all the data because huge amount of data is there. To reduce the size of the data which is going to be uploaded to the cloud. Why? Because when the end users are going to access the data in the edge server which is close to the network, they can access very easily. So the latency is reduced, the delay is reduced. So some time sensitive application which depends, for example, I have set a sensor in my water tank. If the water is overflown from my tank, my sensor should alarm and I should stop the motor, or the motor should be automatically stopped, which is pumping water to the water tank. So this is my IoT application. So here it is time sensitive. The tank is overflowing, the water should not be wasted. So within few seconds or minutes, the motor should be switched off. So this is a time sensitive application. So the data flow from here towards the server and towards the device. Here it is time sensitive application. So the sensor should work connected to the internet, and this application should happen based on time. So depend, if we upload all this data to the cloud and we wait for the data to return from the cloud, it takes more time. So this type of application, we need this edge server, which is going to do all the computation. So it will reduce the time application. So time of the for the IoT devices. So like this, if we take this smart healthcare system, if we take this healthcare system here, uh, here it may be any smart healthcare system. Okay, so here there is an edge node, edge server. So this server is connected to this system. So all the computation of the task related to this system is taken care by this edge server. Okay, only very few data. Okay, after all the processing is over, we are going to upload to the cloud. So we are not going to upload the whole sum of data to the cloud. That is one advantage here. We are reducing the overhead of the cloud. So unnecessary data are not pushed to the cloud. That is the first advantage. Okay. and the data is also processed very quickly because the servers are nearer to the end users. So the applications which are dependent on the time, so time sensitive application, which where the latency should be very less, or the accessing the server or task computation should be done quickly. For that purpose, we are introducing this edge servers. So they are very close to the end nodes. If we take this application, smart home system, here there is an edge server. So like this, we are keeping on connecting n number of edge server, which increases the cost of the network, because deploying a server, it is going to give a overburden of cost only, but it is going to improve your system. So we need to deploy all these. These are said to be distributed. That is why it is said to be open distributed system. So all the applications are distributed over the network, and each and every system is going to depend upon the performance of the edge server. It is going to depend on the performance of each edge server. So now here with this application, we would have understood what is the major role of this edge server. First thing is, it has the advantage of reducing the latency, and second one, the end users are having very less amount of energy. They are working on batteries, so it reduces the energy consumption also, because they are close to the server for a task computation and all those things. And even though if they are disconnected from the cloud, they have fault tolerance. They will be connected to the edge server and they will be working smoothly without any problem. So very few amount of data is going to be pushed to the cloud, so we are reducing the overhead of the cloud storage. So all these things are advantages of the real-time application. So I hope now we would have understood how the edge servers or edge computing is playing the vital role. Again, coming to the classification of cloud computing, we are having various classifications. So we tell that these are the platforms for IoT devices. First one is fog computing. So fog computing is used, which is a platform for all the IoT devices. Okay, I will tell you layer by layer how this fog computing is going to, where it is going to be placed in the cloud. And cloudlets. Cloudlets are nothing but a small, dividing the cloud into smaller clouds that we call as cloudlets. And the third one is mobile edge computing. So mobile edge computing is edge computing, which is going to support various devices which are having high mobility. So we call as mobile edge computing. So before the invention of this mobile edge computing, we were studying as mobile computing. The same thing only, just extended version. Now we are having the advantages of edge computing, and we are calling it as mobile edge computing. So let me see one by one how this classification is going to affect this cloud technology. First, let me define what is cloud computing. Cloud computing is a computing paradigm that which is going to offer on-demand service. So we are going to offer the service, or the service providers of cloud. There are so many vendors are there: Amazon Cloud Service, AWS, and Azure Cloud Service is there, and lot more of people are providing cloud service. So whenever the people are having a demand for any resource accessing or for the cloud technology, they will be providing the service and to the end users on certain cost. So the end users have to pay and they have to use. Okay, so that is why they are called as on demand service. Through a pool of computing resources, usually there will be a group of resources which is available at the background of this cloud vendors. So based on the demand, they will be providing the resources to the end users for this much period of time. What is the cost? So they have to use based on their requirement. So it includes either storage or computing resources like it may be like a CPU, GPU. Okay, so computing resources also it is provided, etc. So on. The key services that cloud computing offers includes infrastructure. Okay, so in infrastructure as a service, platform as a service, and service software as a service. So three type of services are provided by the cloud computing. That we have already familiar with this cloud computing technology. So now the extended technology or the advancement of cloud, whatever drawback we are facing in the cloud, which is being overcome by the extended technologies, especially the first one is fog computing, which involves bringing the intelligence to the local area network architecture and processing the data in the fog node. That is the main concept, which means nowadays artificial intelligence is playing role in all the technology. So every device or every technology is becoming smart with the help of artificial intelligence. So we are going to add this intelligence to the cloud layer, not to the cloud layer. We are going to make it over the fog layer itself, where the routing will be working based on this artificial intelligence algorithms, and resource allocations will be working based on artificial intelligence. So the fog layer will be added with the benefits of artificial intelligence, and it will take care about the uh, resource sharing, or it will take care about the working of the efficient working of the network to the end users. Actually, fog computing was introduced by this Cisco in 2014. Then according to Cisco, fog computing is a standard that defines the way edge should work, based because I will call this fog not as a network. I will tell that usually the people of computer science, or the people those who are working in software industry, they used to call this fog computing as a platform for the devices that is connected to the internet, just like an OS. How the OS is a platform for all the software, like that fog computing is going to be a platform for all the IoT devices which are all connected to the internet. So it is having such a capability. So that defines fog computing is defines the way the edge computing should work. It enables the operation of computing, storage, and networking services. Three operations are carried out by this fog computing in an intellectual way. Computing means computational task. The task, the job, or the data which is generated from the IoT devices. Some task which cannot be executed locally in the IoT devices due to the limitations in their energy and their capabilities of resources. The tasks will be uploaded to the network or the servers in the network, especially in the fog layer. So they will be computed there, and then after computation, the result will be transferred to the IoT devices, and then they are used for storage, huge amount of data. Now all the IoT devices are generating data in the size of terabytes and gigabytes. So we are generating big data. So people, those who are working under data management in cloud technology, they usually deal with big data. So they need a huge amount of storage, and they have to take care of all this storage very efficiently. And networking services between the end devices and the cloud services is very essential. um, why? Because all these end users and networking devices are not properly connected, in the sense we cannot uh, realize the benefit of the network. We cannot realize the benefit if the end users are not actually connected to the cloud in a proper manner. Then we will face we will lose most of the benefits from the network for which it has been designed. So for that purpose, we need to concentrate on the network service. That is why we are adding artificial intelligence to the network services in the fog layer. We are calling it as edge intelligence. There are two type of intelligence are there. When we are adding artificial intelligence in the edge layer, it is called edge intelligence. When we are adding artificial intelligence to the IoT devices, we are calling it as intelligence at the edge, intelligence at the edge or at the end users. So there are two type of intelligence in the network. As per the research, cloud technology researchers argument. Okay. So where is the actual data is being generated and where the data is going to be stored. So the gap between these two is going to decide the latency of data transfer. So when the end users are geographically distributed over the world or over different locations, so they need to suffer a huge distance or huge traverse. Data has to travel for a long distance and by crossing a number of nodes. So this will usually generate latency. So now we are having this fog layer and edge layer as an extension of cloud technology in order to reduce this latency. So we are not going to migrate the data without any reason, which means unless and until if it is necessary for the data to be pushed to the cloud, we are not going to push the data into the cloud. So that is the main benefit of reducing the latency for the data. Next type is a cloudlet. Cloudlet is a concept where the mobile devices will offload their work or task into the resources of the uh, small cloud. So the major cloud is divided into small cloud based on their location. So they are called as cloudlets. So we can also call as local cloud. So that is a subset of the cloud. So n number of cloudlets will be communicating to the upper layer of the major cloud. So that is how the cloudlets are created. So based on locality, these cloudlets is going to play a vital role for the end users. So here we can see that there are some cloudlets can be created for some area where there are some coffee shops or libraries or universities or the transportation systems are functioning. Like this, we can have some different cloudlets at different areas. So that is the advantage of this cloudlets. So cloudlets are going to act as the first hop element for the edge network. So when the data want to reach the edge node, from the data emerging from the edge, it should reach the cloudlet first as the first hop. Then only it has to migrate to the cloud. Like that, the architecture will be. So as we all know that virtualization is the basic concept of cloud technology. Even we can migrate the virtual machines based on the architecture. Okay. So so the purpose of these introduction of these extension of classification of clouds such as cloudlets, edge computing nodes, fog computing, everything is reducing the latency between the end-to-end communication for time-sensitive applications, as well as to concentrate on energy consumption. So the end users are having very less amount of energy. Why? Because they are all working in battery. So they are dependent on energy consumption. When we are computing huge tasks, lot of energy will be consumed. So that based on the energy available for the end user, and also the amount of energy that edge servers or fog servers or cloudlet servers are having, the computation of the tasks should be handled. So energy consumption is also an important challenge for the network. So now coming to the edge computing. So as I have said, it is a distributed open platform at the network close to the edge of the network or close to the end users. So where the data is actually generated. So edge computing is placed close to the place of data generation. So the data is going to transfer at high speed between the end user and between these edge servers only. So which automatically increases the uh, which will increase the performance of the system. So we can overcome the drawbacks that is faced in the cloud. Now, we are talking about mobile edge computing. So mobile edge computing, as I have already mentioned, we were calling it as mobile computing. In the previous version of cloud computing, we were calling it as mobile computing. Um, so that mobile computing only, now a slight modification or a slight extension of mobile computing, we call as mobile edge computing. In the sense, edge computing is going to uh, take care of these mobile devices which are involved in the internet, which are connected to the internet, which are having high mobility. So devices, IoT devices which are having high mobility are going to be connected to the internet, and edge computing is going to take care of their performance or improving their performance uh, for computational tasks. So that is why we call it as mobile edge computing. So it offers application developers and content providers, okay, the capabilities or IT service environment, okay, to the network. It is going to provide these capabilities, different capabilities which is required for the network. For high performance network, it is provided by this mobile edge computing. This environment is usually characterized by low latency, ultra low latency. We can say that it is going to reflect very low latency, and also high utilization of the bandwidth will also be felt. We can realize that when we are implementing this concept of fog computing, cloudlets, and edge computing, the bandwidth will be highly utilized by all the end users, so that the end users can realize a very good internet connection, so that they find harmony in accessing the internet. Here in the diagram, it is mentioned that how the layers are placed in the cloud technology. So the uppermost layer of this pyramid is cloud layer, which is represented in the different color. The middle layer is a fog layer. You can see that on the right hand side of the pyramid, the devices involved in each layer is also shown in the diagram. You can see some devices are there, some diagrams like. So fog layer is having its own devices. Then at the bottom there is a larger pyramid. So which is that layer we call as edge layer or end user layer. User layer. End users are available in this layer only. All IoT devices are available at the bottom layer. So edge computing will act in this layer only. In between fog and user layer only, edge computing will play the role. Left hand side, there are some parameters or characteristics which is mentioned. The left hand side parameters will keep on increasing as we move from bottom to top. Example, reliable connectivity. Connectivity will be Reliable connectivity. We are talking about reliable connectivity. So the connectivity will be very less when we are at the end users, and it will be very high when we are at the cloud level. That which we are talking about reliable connectivity. The connection should be reliable for more amount of time. Okay, in that sense, reliable connection is less at the bottom layer, and a reliable connection is more at the top layer. And another parameter, computational power. End users require very less power, so even they can run on batteries also. Very less amount of energy is required, power is required for functioning. But when we go to the top layer, cloud servers, they are huge amount of resources are there which has to satisfy the end users requirement. They need very huge amount of power consumption, so that is why it increases at the towards the top of the layer. Then data longevity, data storage, reliability, we can see that latency also increases towards the top layer. So latency will be less when we are at the bottom layer, latency will be more on the top layer. That is why when we are using cloud technology, when we are transferring the data to the cloud and return, and the data returns to from the cloud to the end user from one location to another location, it takes more time. That is why we are placing the edge servers close to the end users. Only certain amount of data which has to be pushed to the cloud is going to alone is to be transferred from the edge server to the cloud server, not the huge amount of data. And the right hand side, there are some parameters like location awareness, mobility support, geo distribution, responsiveness, interaction, delay jitter, device, number of devices. This increases as we move from top to bottom. So this is how the picture is going to give a clarity about the architecture of the fog computing, cloud computing, and edge computing. I hope you would have understood in this diagram. So we all know that the company Nokia, which is which is working uh, on network especially. So Nokia networks or Nokia company is providing solution for mobile edge computing network, mobile edge computing technology. Using mobile edge computing technology, Nokia networks is providing solution for all the problems related to mobile network. So which is a real time most of the real time applications are solved by this Nokia networks company. Now still I have given like a hierarchical diagram, hierarchical representation for the classification of edge computing. Here as a summary, we can see that as a summary, I am concluding, I am classifying the edge computing, which is the next level of, that is the layer above the edge computing, can be said as fog computing and cloudlets. Or the edge computing can be divided as a fog computing, mobile edge computing, and cloudlets. Three types. We can categorize this edge computing as three categories. So fog computing will deal with certain issues or problems like big data analytics, resource management, security and privacy, real-time applications, etc. Mobile edge computing will take care of service management, resource management, security and privacy, and real-time application. And cloudlets also related to where to place the cloudlets and how to divide the cloudlets, like that it will be working on security and privacy, resource management, big data analytics, especially collaborative computing. We need to sometimes collaborate edge computing and fog computing. Sometimes we need to collaborate fog computing and cloud computing. Sometimes there may be a situation or scenario in which we need to collaborate cloudlet with mobile edge computing. So we can when we are collaborating more than one technology, we will get the benefit of the one as well as the benefit of the other, which will improve the overall performance of the system. That is why we are using. So when we are when you are collaborating the system, we can get the benefit of both the systems. That is the main advantage of collaborative computing. So the next diagram here, we are this diagram elaborately clearly explains about the architecture, the fundamental architecture, how the edge computing has to be deployed. You can see that there are basically majorly 4 layers are there. First layer is smart service layer. The next one, service fabric layer. Then connectivity and computing layer. And then bottom layer is edge computing network layer. Okay. So if I tell about the bottom, there are some components under network and computing and storage. These are the 3 major um, operations that the network is going to handle. It has to take care about network services like bandwidth and connectivity, reliable transmission, fault tolerance, etc. in the network. Then computing, a computational task, how the tasks are computed, energy required, power consumption of the task computation, what are the data resources required. So that is computing. And storage, the results after computation should be stored somewhere. Okay, so for that we need a huge amount of storage, which may be even big data, and that data may be even big data, which needs a storage at various locations or in the cloud or in the edge servers. So that is a storage, 3 major operations. Now I am going to explain from the top layer, that is a smart service. Okay, let us see what is smart service. Smart services are based on the model driven unified service framework, intelligent coordination between service development and deployment. Okay, so we can see that there are 2 classifications. One is separated with blue color and one is separated with the gray color. So the blue color represents development service framework. The gray color represents deployment and operation service framework. So these 2 sections are collaboratively we call as smart service. Okay. So in development service framework, first step is to develop, then we need to integrate, then verify it, then finally we have to deploy it or release it. This is development service framework, steps involved in that. And in deployment, when we are going to provide the service after development, we are going to provide the service to the end users, service or orchestration, and then application development, then application marketing. So 3 stages are there. So which is taken care in deployment. So together we call as smart service layer. Okay. And then next layer is service fabric. So in service fabric layer, here what is taken care is how the edge to edge service is taken care, which means one edge, there are some devices in one edge network. There are some other devices in edge network number 2. So these 2 devices want to communicate. That is, one device in one edge and another device in another edge want to communicate. Then that edge to edge service will be taken care by this service fabric layer. So here the diagram also represents it is a connection between the routers. So between one network to another network, it has to pass through gateway. So that it is E to E service flow, which is taken care of by service fabric. Okay. And then connectivity and computing fabric. Okay, it takes care about the connectivity of different resources. Okay, and also computing in task calculation, task computation is also taken care in CCF layer. Then edge computing node, edge computing layer, there will be some smart assets, smart gateways, and smart systems for storage. Smart assets are used for network service. Smart gateways are used for computational purpose. Why? Because nowadays the intelligence is placed in the routers only, routers and switches for efficient routing and routing of data in the network. So that is, smart gateways are involved in computing and smart systems are involved in storage. So this is the architecture of edge computing, how they are going to deploy in the real-time scenario. Next, let us discuss any. I will take only one case study, and I will try to demonstrate how it is going to affect edge computing is going to affect in real-time application. I have taken the case study as intelligent transport system, where different systems or different vehicles are going to communicate with each other. So one vehicle can communicate data with the other vehicle. For example, when we are traveling in the vehicle, we want to know where is the nearby fuel stations. So nowadays, every vehicle is behaving as a smart vehicle because they are having onboard unit as IoT device. So each vehicle is considered as one IoT device. Each vehicle is going to generate a huge amount of data. So they are running on map. Gmap is there. They depend on map for route. They depend on various information like what is the next station, how many distance, how much distance is there, what is the traffic level of the road, and so much other data are required for this vehicle to travel from one location to another location. For a certain vehicle, it needs fuel. It want to search where the nearby fuel station is there. And parking also nowadays, plateau parking is there. Automatic parking systems are there. And certain vehicles are now added with intelligence. They are behaving as self-driving cars are there. They will drive without the driver. So in such case, they will generate a huge amount of data. So all these things are time sensitive application. Okay. So when self-driving cars are running on the road, they should not collide with a nearby vehicle. They should not involve in accidents, and they should get the data at right time so that they can travel without the driver. So in such case, intelligent transport system is dependent on edge computing since it is a time sensitive application. Not even in this application, even we can avoid a collision of huge trains where the loss is more. We can avoid a train if this edge computing is there in even in network. We can avoid huge these accidents and all can be predicted in advance and they can be stopped also. So for that, it is a very good implementation where the latency of data is very less. So such time dependent application, time sensitive application can rely on this edge computing architecture. The diagram clearly shows that the top layer is cloud layer, where it stores cloud data. So middle layer is mobile edge computing layer. So there are many number of roadside units and vehicular edge computing servers are there, storage devices are there. So RSU1 represent first roadside unit server, second one is RSU2, like that, etc. up to n number of roadside servers are there. Now you can see that the circle represents n number of vehicles inside one network. They are connected to RSU1. The second circle represents some vehicles connected to RSU2. Like this, when they move from, since vehicles are having high mobility, the handover of the network is a challenge for the people, those who are working with the vehicular communication. So network handover should be done properly so that they don't lose internet connection while communicating with the nearby vehicle or while communicating with the edge server, or they are communicating to the cloud. So reliable communication is required. So the network handover is a big challenge in this edge computing, vehicular edge computing. Okay, so the diagram represents a very good, very clear real-time application, which is an example of intelligent transport system, which is a part of smart cities. Nowadays, every country is becoming smart. So they depend on making their cities smart. So smart transportation system is also a part of it. So this intelligent transport system plays a vital role in making their cities smart. So for that, this is an important case study where edge computing is going to play a vital role for these such time sensitive applications. Now, what are the basic requirements for this edge computing? So we can see that huge amount of that requirement which has been placed in the slide. We can see that so many requirements are there. If these requirements are not satisfied, then we cannot implement edge computing. So all these are basic requirements. For example, security is required. Whenever data is transferred to the edge server for computation, there should be certain level of security. Otherwise, the data will be uh, 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 hacked by the intruders. So it will become a problem. So security is very, very important. Resource management, utilizing the bandwidth, and huge amount of edge servers are required for deploying edge platforms or creating edge nodes. So power consumption for edge servers and end devices, and dedicated computing network is required. So like this, a lot of requirement is minimum requirement is there for getting the edge computing technology to be deployed in any real-time application. So here now characteristics, there are various characteristics are there. So characteristics, first one is dense geographical location. It is distributed over dense geographical location. So the network administrators can facilitate the location based on activity, okay, service from where the service is requested using WAN wide area network. Then big data analytics can be performed rapidly with a better accuracy. Okay, the edge systems can experience the edge systems um, can able to realize the data in real time. Okay, so in large scale. So these are the minimum characteristics of edge computing. Then mobility support, high mobility of end users is supported by this edge computing. Okay, every end user will be provided with a locator ID. They will have based on that they will be identified in their network. Then location awareness using high sensitive GPS systems, or nowadays high performance GPS systems have been there available in the market. So location awareness for the various nodes which is connected in the network, that is also possible. And then mm, proximity in edge computing, computational resources and services are available in the proximity, which means very nearer to the user and can improve their experience of these network devices. The availability of computational resources is available in abundant, and the service is provided without any disconnection. So the end users will be finding very good with their network connection and connectivity or transformation of information. Okay, especially it is called as task offloading or computational offloading in edge computing. That is a major uh, challenge in edge computing. So low latencies and characteristics, very good advantage of edge computing. It provides or it provides connectivity with low latency. So time sensitive applications are dependent on edge computing. Then context awareness, the data is transferred to the nearer edge server. So the context of the meaning of the data or the semantics of the data does not being disturbed. Since the location of data transfer is very less, the distance between the end users and the processing node is very less. So context of the data is maintained. So that is also advantage. Finally, heterogeneity means different type of end users, different type of IoT devices can connect to the network, and they can take the full advantage of edge computing, which is a major advantage of or characteristics of this edge computing. Finally, though there are so n number of advantages, Now so many challenges are there which are open to all the researchers for uh, to open their platform in edge computing for research purpose. So many challenges are there. So few challenges I have listed out here. So the trust on network edge computing systems, that is security, privacy and security has to be preserved, for which we need to implement any new technology like blockchain technology or any uh, cryptography algorithms. So for implementing security over the edge computing networks. Then dynamic, highly dynamic. The network is highly dynamic due to high mobility. So then pricing models. These are the important challenges here. Then quality of service. Providing high quality of service is an important challenge here. So a lot of research is undergoing is have been going on to improve the quality of service for satisfying the end users requirements. Then collaboration between the heterogeneous edge computing systems, so heterogeneous network. Then fault tolerant systems has to be developed and deployed. Okay, all these are challenges open to the researchers for edge computing. So I would kind of like to conclude my edge computing e-content resource delivery with this. Thank you. Thank you, one and all.